Oh, page completed. Complex numbers, ninth one. So what is the equation? X square plus x plus 1 by root 2. Yeah, is equal to 0. That's all. Right, students.
And take LCM denominator, sir.
Take LCM. Yeah, you can take LCM, or else we'll do directly also. I'm going to do directly. If you want, you can take LCM. Okay, now I'm going to comparing with ax square plus bx plus c is equal to 0. So in NCERT, how will you write? Let us take this is equation 1. Equation comparing with the general form ax square plus bx plus c is equal to 0, which implies we are going to get a is equal to 1, b is equal to 1, c is equal to 1 by root 2. Right? After that, what shall we do? And comparing, after comparing, we obtain like this. After obtaining all this, therefore the discriminant of given equation, therefore the discriminant
Sir, why can't we make the equation as root 2x squared plus root 2x plus 1 equal to 0?
root, yeah, you can make it. That all I'm telling, you can take like LCM, that is root 2, you can cross multiply, it will become 0. Okay, like that also you can do. It's better to you can do directly. That is my advice. Both the way it is correct.
Sir, if we take LCM, you will get more simplified way, sir.
But here in NCRT, that is most easier. Okay, but in NCRT, if it's better to do directly. For example, some questions are there here. This question is there. What we have done here, we can do in two ways. You can take minus common. We can do. Or else we
Sir,
do
we
that.
can take the equation to the right hand side and we can simplify also, no, sir.
Yeah, that is
Then
only.
it will become positive.
So in this question, what we have done actually, we have done directly. But you may do like after taking LCM also, after taking minus common, so minus here plus. In like that also you can do. So my advice is you can in NCRT, you can do directly instead of taking minus common, instead of taking LCM here. It's better to do directly. Yes, clear. What is the discriminant here? B square minus 4 is B value is 1 square 4 times of 1 into 1 by root 2. So we have to check whether it is, yeah, what about your 4 by root 2? Nothing but 1 minus 2 into root 2 into root 2 by root 2. Root 2 get cancelled. What about capital D? Then capital D is equal to 1 minus 2 root 2. Is it greater than 0 or lesser than 0? Yes?
Less than 0, sir. Because 2
Lesser
root 2
than 0.
values 2 into 1.4. Greater than also.
Yes, it is clearly lesser than 0. So therefore, what shall we write? The required solutions are. The required solutions are. So what are the required solutions here? X is equal to formula minus b plus or minus root over b square minus 4ac. I'm taking as capital D by 2a. That's all. So minus b means minus 1 plus or minus 1 minus 2 root 2 by 2 into, yes students, 2 into 1. So after this,
That's all we got the answer.
it's better to, you can write like this, 2 root 2 minus 1 into iota. Actually 1 minus 2 root 2 is lesser than 0. We can make them to greater than 0. After that iota you can write by 2. That's it. These are the required. So what are the, there are two solutions. Yeah, this is by 2, this is by 2 into iota. This is one of the complex root. Another complex root is minus 1 by 2 minus 2 root 2 minus 1 by 2 into iota are the required solutions. That's all. These are the required solutions. Yes students, any other doubts? Any other question will do? Question number 10 also, it's better you can do directly.
1 minute, can you show the solution, sir?
Yeah.
Last, sir.
Also, sir.
Completed. Next exercise is miscellaneous exercise. Yes student.
Can you take some 14, sir?
Example.
14.
This example you want?
Yes, sir.
Yeah. Right. So right, tell me what is the question? X plus iota y is equal to a plus iota b by a minus iota b. Then we can show that
X square plus y square equal to 1.
okay, it is a objective question. For example, let us consider this is a objective question. So answer we can do directly here. Take modulus. Take modulus directly. We will get the answer. So what is modulus x plus iota y? Students.
Root of x square plus y square.
What is the modulus of
Modulus
this one?
Root over x
a square
plus
plus b square by root over a square plus b square
Get cancelled now.
equal to 1.
Now squaring on both sides.
Square on both sides, x square plus y square equal to 1.
That's it. This is objective. Whenever we don't have any iota term, nothing but they applied modulus on both sides. Is there we having any iota? No. No iota means they applied modulus. They have taken modulus on both sides. That is the meaning. But in NCERT we cannot do direct like this.
There we need to find the conjugate and simplify.
Yes, first we change it to standard form right side value. Is this easier RHS is in standard form? No, that is not in standard form. So that what shall we do? First we have to rationalize. So x plus iota y is equal to a plus iota times of b by a minus iota times of b into rationalizing with a plus iota times of b by a plus iota times of b. So what you observe numerator and denominator? Numerator clearly a plus iota times of b the whole square, but denominator a square. Yes, students. A square plus b square. Am I right? Clear. Now after that, what shall we do here? Now this is clearly directly in the form of like denominator. We don't have any iota terms. Now take modulus on both sides. Yes. When we apply the modulus on both sides, whole modulus by a plus iota times of b, the whole square by a square plus b square. We can do in two ways here. You have to expand here. Apply the a plus b whole square. Apply the a plus b whole square, then a square plus b square plus 2 into iota times of b. AB will get. So after that you can take on both sides, or else you may take directly like this. When I take like this, so here modulus of a plus iota times of b whole square by modulus of a square plus b square. A square plus b square already it is a positive value and numerical value. So this will becomes what? This is root over x square plus y square. Then here bracket square root of a square plus b square the whole square by a square plus b square. Now square root get cancelled. This is equal to a square plus b square by a square plus b square. This is equal to 1. Now squaring on both sides. When we squaring on both sides, x square plus y square is equal to 1. This is method 1. In method 2, we have to expand here. So a square plus iota times of b the whole square plus 2 ab. Like a plus b whole square you can apply. Now we are going to get a real part and imaginary part. Real part is a square minus b square. Imaginary part is 2ab into iota. So comparing on both sides, you are going to get x is equal to a minus b square and y is equal to 2ab. Okay.
Why we are taking the root only on the numerator, sir?
Sorry.
Why we are taking the root only on the numerator, sir?
Root where? Here.
Yes,
This
sir.
one. Yeah, what is modulus a plus iota times of b? Modulus. Yes, modulus of a plus iota times of b formula is what? Root over a square plus b square only.
So why are you not taking the modulus for denominator, sir?
Yeah, I have taken already here. See, is here any iota term to
No,
take
sir.
square root? No, that's all. Whenever you are having iota, then only you can take square root. No iota, no need. This is for
Okay.
2 marks. In case the same question they're asking for 5 marks, I told you know another method you can comparing on both sides like that. You can go through method 2. That method 2 is as they asked x plus iota y is equal to, you can write real part at 1 plus imaginary part at 1. After applying a plus b whole square, we are going to get a square minus b square plus 2 ab into iota. Denominator already a square plus b square is there. Yes or no? This is a square plus b square. This a square plus b square, what shall we do? Write it separately. A square plus b square by a square plus b square. This is x plus iota y. In the same way, you have to find x minus iota y. A square minus b square by a square plus b square. Then replace iota by minus iota. Minus 2ab into iota by a square plus b square. Is this clear, students? Now, see here, generally, what is x plus iota y into x minus iota y?
X square
Yes, x a square minus,
plus b.
yes or no? Nothing but x square minus iota square y square. What is iota square?
Minus
Minus
1
I
Minus 1. Minus into minus?
plus
Okay, fine. Finally, this is the LHS of given question. In the given question, what is the LHS? We can prove that x square plus y square. Okay, x square plus y square, we got it here. I'm finding this one. The same values. What is x plus iota y? You have to multiply RHS also. I multiplied LHS values. I multiply these LHS values. You have to multiply RHS values. RHS values is here. Here a square minus b square by a square plus b square plus 2ab into iota by a square plus b square into a square minus b square by a square plus b square minus 2ab into iota by a square plus b square. Now what do you observe here? This is in the form of a plus b into a minus b. So what is the value? A square minus b square by a square plus b square the whole square. Yes, minus 2ab by a square plus b square the whole square. So finally I applied here. This is a plus b into a minus b. That's all. A plus b into a minus b. A square minus b square. So a square minus b square the whole square by a square plus b square the whole square minus 4a square b square by a square plus b square the whole square into iota square. Fine. Now, is here we having any common LCM? Yes, a square plus b square the whole square. Numerator is a square. Yeah, apply this. A square a power 4 plus b power 4 minus 2a square b square minus into minus. I square value is what, student? Is I square value?
minus 1.
Minus 1. Minus into minus.
minus 1
Shall I write plus
plus sir.
4a square b square? Now, 1, 2 get cancelled. Minus 2 a square b square plus 4. Plus 4 nothing but just plus 4 becomes what?
a square plus b square the
2.
whole square.
Exactly. So here we are going to get a square plus b square the whole square by a square plus b square the whole square. Get cancelled. It is, yeah.
You have written b square instead of b power 4, you have written b square, sir.
Yeah, okay. This is
Last
b
word.
power 4. Right. Like that. This is the solution when they're given for 5 marks. Like that you have to do. 5 marks or 3 marks. For 2 marks, you can do directly. Take modulus on both sides. You can do that like that. Clear? All
It's a-
examples
Can you show the solution?
all examples also very important. I rationalize. It's better to do after this step immediately. You can do like this for 3 marks.
Sir, we can do what way we are convenient now, sir. But there should be more amount of steps.
Sorry, what?
Sir, what way we are convenient, we can do the method now, sir.
See, it's that only it's depending on the marks. If it is it may be the same question they may ask for 2 marks, 3 marks, maybe for 5 marks. Okay. So if they ask for 5 marks, we cannot do directly step. We cannot apply direct modulus on both sides. If they give for 2 marks, directly take modulus on both sides, we can complete it.
So we have complex number it's an objective also, sir.
Objective?
So we have complex numbers in master G also, sir.
Yeah. It is important, no? It is in class +1 only. Relation functions alone we will discuss in class 12. Other than all the chapters, OBT part we will discuss in class 11, +1 only. Okay, now let's go for miscellaneous. See, when you see here, see all, so here in complex number, actually this is very interesting and sometimes quite difficult if you are not attending all the classes. OBT. See, I will discuss about complex number. Conjugate of complex number, we know that properties also okay, easy. And square root, in OBT we will discuss square root of a complex number. This is important. Here a few topics are there which is belongs to advanced. See, this properties and all easy, no problem. After that, see, modulus of a complex number also okay, we studied already. Properties of modulus of a function. These are the few properties are there. A plus b whole square, a minus b whole square, those formulas. Inequalities we will discuss already. One chapter is there in class 11. So if you understood those concept like inequality, so this
The
inequality
inequalities is wavy curve method only, no, sir.
wavy curve that belongs to real number system. Yeah, we can do with help of wavy curve method, right? Here the same inequality property we can apply for complex numbers also. Yeah. Next, after this, see argument. Principal argument already studied. So this is 2k pi plus 2k pi plus theta. This is called the general argument. This about general argument we will discuss after start. So already we discussed this principal argument already. So different quadrant. I already explained in first quadrant it is theta. This is theta. Theta nothing but tan inverse y by x. That already. So this is I told you already pi minus theta. This is theta, no? Pi is there. Pi minus theta. Third quadrant. See,
Minus of pi minus theta.
minus of pi minus theta means minus to minus plus here. Minus pi here. Minus theta.
Minus theta.
Whenever this is theta, this is whole minus. Don't confusing about this. Okay. So it's depending on x greater than y. First quadrant is theta. Second quadrant pi minus theta. Third quadrant minus.
Sir, is this for least positive argument or principal argument, sir?
Principal argument alone. Yes or no? See, first quadrant I have taken no theta here minus theta. Pi minus theta.
Principal quadrant you will consider third and fourth as negative, sir.
Yes, that's the reason here. If you take whatever I have written, they given here. When you take minus here, minus. That's all. See, this is x greater than 0. X greater than 0, y is equal to 0 means on real axis. The point lies on the real axis. What is the angle? Students, on the real axis always we know that
0.
when x 0, y greater than means on imaginary axis. What is the angle? 90. When x 0 and y is negative, y is
Fourth quadrant.
This is quadrant here. And here finally x lesser than 0 means negative here. Y 0 means here. The angle is plus pi.
Positive 180 degrees.
Yes. Understood? So after that, some important result on argument of Z, argument argument of any complex number can be denoted by ARG of Z. These are all we'll discuss this in general way. Here cis theta is there. What does it mean by cis? Cis theta. Cis theta nothing but this already we know. C nothing but first cos theta plus I. This is I is an iota times of S nothing but sin theta. Understood? Cis theta. Here this is the way of writing shortcut method. Cos theta plus I sin theta. Instead of writing cos theta plus I sin theta, they have taken as cis theta. Cis of minus theta means cos of minus theta plus iota times of sine of minus theta. That is the meaning of cis side. Here cis theta 1 into cis theta 2, cis theta 1 by cis theta 2. Okay, we can write in shortcut method.
Sir, they have given cos h theta. What is it, sir?
Cos
H theta.
h theta, hyperbolic functions. H means always it will represent hyperbolic. We know that sin x, cos x, tan x, secant, cosecant, cot. Instead of x, if they given sin hx, h. When you see h, nothing but this is hyperbolic functions. Hyperbolic function. There are same 6 hyperbolic functions are there. Even inverse hyperbolic functions also there. Like sin x is there. This is trigonometric function. Inverse trigonometry of inverse of this sin x is sin inverse of x. This is sin x, a trigonometric function. This is inverse trigonometric function. In the same way, sin hx will be there. H, when you see the h, this is hyperbolic function. Then sin h inverse of x. This is inverse hyperbolic functions. Okay, everything we'll discuss in further classes.
Sir, how can we represent hyperbolic, sir, in graph?
Yeah, hyperbolic means actually, hyperbolic function, that is parabola, hyperbola, ellipse concept is there. Once we start that geometry, in that first we will study about straight line, then circle, next parabola, hyperbola, ellipse. So entire geometry we'll discuss in class 11th. So sin hx nothing but it can be represented as e power x, e power minus x by 2. Okay, with help of exponential functions, we will discuss about hyperbolic function.
Sir,
Even
here E will take us Euler's number, sir.
Yeah, here Euler's numbers in complex. In complex number, we are using e power c, e power 90, e power 360, e power 180, e power minus 90. Like these are all called Euler's. Euler's theorem is there. In Euler's theorem, we can represent in terms of e power something, e power iota theta. See, I said what is cis theta? Cos theta plus iota times of sin theta. This is also can be written as e power iota times of theta. So cis theta is equal to cos theta plus iota times of sin theta. That is equal to e power iota theta. Nothing but cis is equal to e power iota times of theta. These are all we'll discuss. No problem. Just I'm showing what are the topics are then complex number. So principal modulus amplitude form of a complex number, that is called polar form. Okay, then argument, amplitude of a complex number. Then after in that, these are the properties. Euler's form, as you said, Euler's form. First write polar form, after that this can be represented as R into, I told you, cos theta plus I sin theta can be written as e power I theta. This is known as Euler's form of Z. And this logarithmic of a complex number also important only. So 1 or 2 properties are there. These 2 properties you have to remember. Log I. Log iota is equal to iota times of pi by 2. This is another formula. Here, few questions is important geometrical result. Geometrical result is there. So this actually geometrical result, or they may ask in advanced level. So it is belongs to like equilateral triangle, orthogonal. So circle, ellipse, how to represent in complex form circle, And parabola, ellipse, hyperbola, even straight line also, how can we represent in complex form? Area of triangle. So see, almost nearly a locus of a complex number. Straight line. This is advanced concept. Circle.
What is locus, sir?
The locus concept means locus nothing but the set of all points will satisfied some particular point. That is called a locus. For example, let us take, I'm taking a fixed point here. I'm taking a moving point here. This moving point, it satisfies one condition. So wherever you take the moving point from here to here, it is moving, but the distance will be same. If I take distance is r, here also distance is r. When I take moving point come to here, the distance will be same r from the fixed point. This is fixed point, this is moving point. The point is moving in equidistance from the fixed point.
Then it will be circle, no, sir?
Yeah, this circle is called a locus. Locus of all these points will give a circle. Means it will be satisfy. All the points satisfy certain properties. What are the properties? There is a fixed point, there is a fixed distance between.
So it is like finding a modulus value, no, sir?
It's okay, yeah. The distance between this, if I take this as p, a moving point is q, pq is equal to r. So it is one of the equation. Okay, the set of all points satisfy the given equation, then this will give you a locus. So locus, here separate topic is there. If we have sufficient time, we will discuss that local concept. Okay, if I explain 1 or 2 minutes, you may not be understood. We will discuss very briefly. So like see here in complex number, when you see almost this is 8, yeah, time.
Time up, sir.
I know, I know. The properties alone, how many pages are there? Nearly 10 pages, 10 to 12 pages are there. Give more. So, and also here the thing is, here we don't have any third exercise, complex number. This cube root of unity, nth root of unity, also very important. So totally 13 pages are their properties. Clear, Amma?
Sir,